what are the attributes of a good data scientist, machine learning, and what emerging skills do you recommend for students or aspirants who wants to enter the data science, machine learning, and AI space?
Ooh, I'll go first. So I think one of the things that drew me, I was not looking to leave the federal government when I went to Maryland. I had a fun program that I was able to develop and was leading. But one of the things that drew me to Arliss is that we focus on the human domain aspects of hard problems, right? And that is, how does the human fit in with all these things? And we're really taking these socio-technical approaches. And this goes to actually Ryan's second question that I just answered in the panel chat there. But it's data science isn't all about the data, and it's not all about the tech. You have to understand the people side of this, right? Where do the people fit into that? How, who's performing the work? How are they performing the work? How's that work organized? Understanding that psychosocial piece as well as the physical piece and all those interactions between the person with the machine, and then the person and machine working together, interacting with its external environment. So that's I think the key piece is that data science isn't just about data. It's not just about putting fingers on keyboards, ingesting a bunch of information in ones and zeros, watching the electrons, spit across gaps. It's about really understanding how do we augment and enrich the human who's doing a function to make better decisions, because as I think it was Laine's slide about Lee's work in terms of humans being able to adapt. It's very true. Humans are really good at making decisions when presented with high quality information, and in that. So I think you have to understand, what's the purpose of the data science? Is it simply just to do data science for data science, or are you actually trying to achieve some outcome? Who's the stakeholder of that, and really approach it from that perspective? If you did that, you will be far ahead of a lot of other people.
I can also share some of my thoughts. I think I assume all the audience are the engineering students, right? So I think perhaps we first think about what is our core skills, core competence, right? And how to use data science to help us enhance our skills and our capability, right? For example, in material science, there's a huge amount of different microstructure, EBSB, TEM, naturally they are doing a lot of signal processing. In Dr. Lei's lab, there's a lot of the wearable sensors, right, that need a real-time computing capability. Right? So basically, data science is almost everywhere, but don't try to compete. Don't imagine, don't consider you as a consultant. We are still an engineer, right? So identify your research area, your application area, then try to learn the so-called data science to help your further progress in that regard. Right?
Yeah, my only advice in that, it's twofold, is data comes from sources, and if you're looking at, for instance, manufacturing, go out and see the source so you can understand sort of where it's coming from and what the data represent in the physical world. That's one side. The other side is learn some coding. So that's going to be sort of essential now that we're all engineers have to be a little bit of computer scientist now, or at least able to handle the data, format it, analyze it, and there are great tools for doing that. You don't have to invent that. So I think the days of Excel are going to be sort of floating away. We're going to start getting into some more sophisticated tools.